All right. So now the first question that we had, which is the Monday's question, was essentially the goal is to, so the theme for this week was essentially just string based things, and the cheeky thing was that apparently for non-computer folks, a thread and a string, they mean the same things, but for computer science folks, they are obviously different, right? So that was the cheeky theme. But that being said, let's get going and figure out what is the first question, right? The first question is that given a string, find the longest palindrome that you can make by removing letters from it. And this is not just removing continuous letters, it's just removing any letter, right? So who all who all solved it, and how did you solve it?
Vivek, this is Supriya.
Hey, Supriya.
Yeah, so the idea was it was based on dynamic programming, where you build a matrix by checking the length. I mean, build a matrix based on the lengths. Like you check if you can, all the individual letters become your palindromes of length 1. Then you look for palindromes of length 2, and then you do for 3 and for 4 and for 5, and so you can build this matrix, and then you can in the matrix you will get the length of the palindrome that you're looking for, and based on that you can again traverse the matrix to get back your answer, that is the palindrome that you're looking at.
Correct. Makes sense. Makes sense. In at a very high level, it makes sense. It is an approach. So the idea here is essentially you are using a dynamic programming concept where you're saying that you will be taking all single length palindromes first, and then you will have a kind of an algorithm to figure out whether you're going how do you go from a small palindrome to a larger palindrome?
So if the palindrome is like GOOGLE, the Google palindrome, so my matrix will be it won't be filled fully. It will just be half of the matrix will be filled. So my first level will be that I will fill up all the diagonals with 1, saying that G is a palindrome in itself of length 1 and O is a palindrome in itself of length 1.
Correct.
And similarly for all the letters. And subsequently I'll start seeing in the GOOGLE, I'll start seeing GO, that is from index 0 to index 1. So, is that a palindrome or no? And then I will go from 1 to 2. I'll go from GO, the O to O. So, what will happen is, because this is not a substring and we are looking for a subsequence of the palindromes. So, when I do OO, then it continues as OG, then GL and LE, and the subsequent, so the next one will be palindromes of length. When I say palindromes, I'm just panning out for length 3. So I'll say GOO. That's what so my first character is G, the last character is O. I'm checking if G and O are equal and are they palindromes, and if they are equal, then I will check inside them. The idea of dynamic is that once I know if G and O, the outer O that I'm talking about, is if they are equal, then the inside whatever elements I have, do they already form a palindrome or no? I can check with my matrix. So, and then if they do form a palindrome, I'll be adding 2 to it, saying that the outer 2 characters have also got included in this palindrome.
Yeah, so that's what I was suspecting, right? So the challenge you have is that how do you then go to even length palindromes?
So it will do for all lengths, right? It will do for 3, it will do for length 4, it will do for length 5.
How will you do? You see, the way you go from 1 to 3 is to find a matching left character and matching right character. Now to go from like 5 to a 6, right? That's not easy. Like you can't go from a 5 to a 6.
So if 5, no, when you go to, so if the outer 2 that you're considering are not equal, then it is just whatever is the existing palindrome. So
no, I understand that. What I'm saying is that in order for you, so you need to start not with just single palindromes, but you also need to start with double palindromes, like palindromes of size 2.
When you do single single, the next step is you're doing double. GO you're checking. You're
Not
checking if G and
GO.
O are equal.
Okay, fair enough. So there were so that makes sense. Any other approaches?
Yeah, I was also thinking of the dynamic programming, and I'll write down what the recursion I was thinking. Max palindrome from I to J. I think one is the palindrome I to J.
We are on line number 37. If people are on Etherpad, it's actually a little lower.
J is less than I is equal to 0, like just some boundary condition. Okay. So max palindrome for Pij for others is either if AI and Aj are equal, then just the max plus 2. So P I plus 1 and J minus 1 plus 2. That's the case. Or the max of the two cases I can take is just ignore the first one or ignore the last one, and the max of the two. So max of P I plus 1 J or P I J minus 1. And that should be my recursion condition and base case. And then I go start from the difference between I and J starting from 1, and then keep expanding the difference between I, J to 2 and 3 and 4, and the matrix will keep filling up.
No, why would you do it this way? Why would you not just start with like just try to calculate max, essentially calculate P of 0 to length minus 1 or whatever the length, right? Just calculate this, that's it. Once you have defined your recursion condition, this is your answer, right?
Yeah, this is the answer.
To get to the answer, what it will do is it will try to calculate all the other items one by one.
Yes, yeah. I think I was thinking backward. Forward and backward. Both.
You don't need to do any. I mean, you don't need to do any of that. So does this make sense to folks?
Vivek, this is essentially the same.
In a different, it's just expressed mathematically. This is exactly what you said.
Yes, exactly. And I didn't use recursion. I just filled up the matrix directly using iteration. I mean, there was no need for recursion to do this. That's what I thought. I mean, at least that's why
you're going bottom up, but essentially this will get you the same thing. So there are a few ways to actually solve this thing. But if you look at it conceptually, right, there are only like two basic cases, right? If in order to find the longest palindrome that you have from a starting location to an ending location, if both the starting and the ending location characters are the same, then obviously whatever is the answer of the inner substring, right, that plus 2 is the answer for your out. That plus 2 is the answer, right?
Right.
And then that is the first one. Then the next scenario is that let's say it's not. Then you have two choices. You can either delete the first character or you can delete the last character. Correct? You either since the characters are different, you have to solve without using the first character, or you have to solve without using the last character.
Okay, that makes sense. Yeah.
And that's it. And whatever is the maximum of those two is the answer. There will be a lot of overlapping subproblems here, and you will have to use memorization to store that to prevent duplicate calculations if you have any.
But Vivek, you're saying that you either delete the first character or the last character. But when you add more characters, when you start expanding this and try to add more characters, the first character could have formed the palindrome with the other character that you're adding, or the last character could have probably added to the palindrome. I don't know.
No. Okay, good question. So let's say Google, for example, right? What is the maximum palindrome that you can do with Google? The first and the last characters are not the same, correct?
Yes.
So it is either max of what you can do with GOGL, or max of what you can do with OOGLE.
Yeah, the max of either two.
Correct?
Max of both. Max of
the
both.
max of this. Okay, okay. And you're starting from the whole string.
Yes.
I was thinking, okay, from 0. This will work if you start from the whole string, not from like the.
Correct, correct.
Yeah.
It doesn't make sense. You can't start from any random location. You start from the whole location, right? So now, if for whatever reason, right, it was like it was e-Google, right? If this were to be the character thing, right? If it was e-Google, then the answer is very simple, right? It is actually the max value that you can extract, like the p value that you can extract out of the string, which is GOGL plus 2.
Right.
Because you consume the 2 e's. That's it. Those are the two cases. Once you build this base case, it's like a 5-line program that you can write and you're done.
Right.
Make sense?
Yes, yes.
Okay. Any questions or any concerns with this approach? So the message here, the way I see the message is that Supriya, the method that you are actually describing is actually no different from this message. Okay, but it's very hard to code. Like depending on your problem, you may actually have a way of going bottom up, or you may have a way of going top down.
Correct.
Okay, so you have chosen the bottom up way of doing it, and I think you will come up with the same answer and same solution. But there are a couple of challenges here. So going bottom up, right? So essentially all the savings that I was talking about, right? The memorization will essentially be the table that you're building.
Right.
And you can build the table bottom up, or you can build the table top down. The top down table building structure is actually much simpler and more intuitive to think about, but nothing wrong with the way you are doing it as well. Okay.
Okay. Right. So, So you whatever you are telling is like the top down approach. That's what you're saying, right?
Correct.
One
correct.
is top down approach. Right.
Correct. Okay. Awesome. Any questions?
Actually, this seems more intuitive when the way you explained it. Just. Probably it's easier to come up with this if you think on these lines rather than come up with the bottom up approach, which seems a little more complicated. But that's fine. That's what I feel. Okay.
Awesome. Any concerns? Any questions? Or shall we just move on to the next one? Right? Okay. So line 47, right? 47, 48 is where I am, and pick the next one. Okay. So this one's actually a slightly easier question. It's very common. It's got a few things that actually that are different for this one. So the question is, have you guys played Scrabble? If not, essentially Scrabble is a game of where you have tiles from A to Z. There is also a tile which is a blank, which can be used for anything, and you're supposed to form words out of it. And Scrabble has like different scores that are given, like A is 1, I think B is 2 or 4, like B is 4, C is 4 points, and like D is 2 points, G is 2 points, O is 1 point, or something like that. So if I give you the tiles like D, B, and A, right, you can actually make multiple words out of it. Like bad would be the word that you can make, which is one of the words, and this will be worth 7 points. Okay, so the goal here is for you to figure out, if I give you 8 tiles, and the input will be given to you something like PRES question mark. That's it. Okay, question mark indicates a blank, or sometimes an underscore, depending on how you want to code it. Now this is how many 5 characters, right? How will you find out what is the one that actually gives you the highest score?
What is 8, Vivek, before the word?
Well, 5 to 8 tiles. So.
Oh, okay, 5 to 8.
Okay, so how do you solve this? And other folks as well who are on, Kanika, Rajiv, feel free to pitch in. And even if you have not solved this question up front, feel free to suggest right away. Like start pitching in. The more you participate, the better it is. Vamsi, same for you.
And the list of words is given to us, right?
You are given a dictionary, and yeah, let's assume it's there.
Okay.
Anyone Any attempts?
Yeah, so I was thinking put all the words in a try and then start walking the try and pick the maximum available letter which you haven't picked, and if try node has a child of the matching maximum, then go down that path and you keep going down at least 5 levels, and if you get a match between 5 and 8, you remember your maximum sum so far, and if you don't go beyond 8, and if you see a match before 5, for 5th level, ignore it. Try to go down.
But how will you deal with underscores, which is basically the blank, right?
So okay, at every try node, pick the maximum. Okay, so underscore.
Underscore can be anything, but it is scored as 0.
It's scored as 0?
Yep.
Okay, so if a try node doesn't have any value attached, so if all my numbers are consumed or not one of the child of the try node, then I should use, actually 0 I should always, the underscore I should always take as an optional branch in my recursion. Once I go down that first and come back on the same try level, I use that underscore to look at all the remaining branches out of that tree.
So think about it.
Then I consume my underscore after that.
Fair enough. Anybody else with any other approaches? Supriya, feel free to jump in and suggest what you think, even if you have not attended it before. Same thing for you, Rajiv.
Vivek, I guess I'm missing something in the question. Why is it that some tiles have, like in the first column, right? B has a value of 4 and B also has a value of 3. That means?
Where is it? Where does B have 3 and 4? Where exactly?
The picture that you have posted.
Oh, the picture is actually, one is the count and one is the score. I think it's one. My miss. I think it's 2 different styles of Scrabble. Pick a number.
Oh, okay.
My miss, actually. I'm just noticing it now. The official Scrabble, I think, has B as 4, not 3. Okay. So there is a score. That's it. So B is 4, C is 4. So how do you solve this? What's the first thought that comes to your mind? I mean, imagine this is an interview and this is what I'm asking you, right? I'm saying I've given you Scrabble tiles. Scrabble has these numbers, and every tile has a score. You're given a dictionary. Tell me the highest scoring word that you can form with these tiles. You may have underscores, or which essentially represents blank. There are 2 blanks essentially totally from the tiles. So there may be actually multiple blanks if you, right?
Will you think of, sorting them by their weights, in the sense Z has 10, so try to figure out, order them by the highest, 10 to whatever, least one, and then how do you form words next? I don't know. Probably.
Are you trying to be greedy here?
Yes, kind of. Yeah, not kind of, greedy only. 10, if I'm saying sorting, that means I'm trying to say that Z comes first because it has 10, and something else which has 10, like Q has 10, so that is also coming along with Z. So then you try to form words. Now, how you can form words which very effectively is probably with the try that one of us was suggesting. So with Z, you'll see what other words you will probably be able to form. And you will...
If I give you the words like zoo and joke, right?
Yeah.
Zoo you can form with 12 points. Joke is formed with 17 points. Right?
Oh, okay. All right.
So if I give you Z, O, O, J, K, E, right? If these were the letters given to you, you will try to form zoo first, right? Whereas joke is even better. So how would you go about doing this? Like, what's the so there are multiple problems going on here, and we need to start thinking about picking these problems apart, right? The first problem is Scrabble is all about anagrams, right? So you're trying to figure out with the tiles which arrangement of the tile actually gets you the answer. But the scores are not positional at this point. So which means that instead of actually arranging the tiles to form the words, you should actually arrange the words in a specific order in the dictionary. Go to the dictionary and pre-process all the dictionary so that every word is actually alphabetical. So bad and dab all get converted to ABD. Right? Because the score for bad is the same as score for dab. Why do you care?
Yeah, exactly. Yeah,
that's the first step.
I think that's, yeah.
Okay. Then the second step would be to now you have like, and essentially this tells you that you need one A, you need one B, and you need one D, right? What do you have? I have one P, I have one R, and I have one E, and I have one S, and I have one blank, right? Ignore the blank. You don't care about the blank. So can I make a bad with the letters I have? No. Because what is the delta? What is the difference between these two? Right? I still need a A, I still need a B, I still need a D, correct? So far with me?
No, you are given a set of letters, is it?
Yeah, you are given a set of letters, right? So let's say what you get. Let's talk about this. What are you given? You are given P, R, E and two blanks. This is what you're given. Okay?
Okay.
Now you have converted a dictionary and you have A, D, B available. Can you make A, D, B with P, R, E?
No.
And two blanks? No, because after you have actually subtracted P, R, E from A, D, B, you are still left with three tiles to go. You still need 3 tiles, correct? To make A, D, B.
Right.
Okay. Now what about ear? Like either A, E, R, right? How many more tiles to go? Just 1 tile to go. Because you are able to match the E, match the R, but you're not able to match the A, correct?
Right.
Okay, so now whichever tiles you have matched contribute to the score. So that is like probably 2. Because A is 1 and R is 1. E is 1 and R is 1. Whatever you haven't been able to match, you still have 1 tile to go, and in this case, since you have 2 blanks, you can make this word.
Okay.
And that's it. So what you're doing, so think of it this way, right? So whenever you're actually looking at anagrams, the converse, it's always worth looking at it from the opposite direction. So for every problem, so you're looking at from this, instead of trying to figure out if you can make the words from this, it actually makes more sense to see if you can actually convert the dictionary to an anagram dictionary where you've sorted all the letters. Now it becomes a case of simple lookup. Okay, and then you know how to score it, and you know how to keep the maximum score. So that becomes like a simple way of solving this problem. Does that make sense?
Yep.
Any questions?
No. Vivek, so you're saying that, so what's the highest scoring word? So what you will do is, you will just order the dictionary as, you will, by the lexicographic ordering, you are going to get the individual words as well as the whole dictionary itself, and then you will calculate the score for each and find the highest score. Is that what you're saying?
You don't have to do it lexicographically. You can actually do it by their scores.
Okay.
Yeah.
So you will actually be putting, and not just so the ordering, right? You don't have to order it as A, B, C, D, E, F. You can order the letters as like in the same, as long as it's a canonical order, right? You're fine. So you can have Z, then Q, then J, then whatever X, and so on, right? You can have an order that is, as long as that the letters of the alphabet are in the same order regardless of how you sort it, right? It doesn't have to be A, B, C, D, E, F, G, H. So if you sort it in the Scrabble score weight order, then the chances of you finding the better score up is actually higher.
Okay.
Yeah, then you stop at your first match. First thing
Correct.
you can make in the...
You stop at the number of mismatches. Once you have a set of mismatches, you can actually kick the word and move on.
Yeah.
Okay, and you can also trim the dictionary to exclude words that you cannot make anyways by size. But those are all pre-processing that may not actually give you a whole lot of bang for the buck. Depends on how often you want it. Okay. So anyway, I mean, it's not a very hard question, but it just requires you to put 3 or 4 different concepts together and try to get it going. Does that make sense?
Yeah, makes sense.
Okay. Any concerns? Any questions so far?
I guess, Vivek, I somehow didn't catch the answer.
Oh no, go on. Repeat.
Got it. I don't want to take the time away and go on, but
please state your answer. State your question.
no, I didn't. I probably didn't internalize what you said. I missed it somewhere. I understood whatever you talked about DBA and BAD and how the 7 points.
Okay, so let's take a step back. No, that's okay. Let's take a step back and try to explain that. Let's do the answer one more time, right? So the way this works is this. So first, let's ignore the underscores first. Like, let's assume that your word does not contain any underscores. The given thing does not contain no blanks. Let's start with that case, right?
Right.
Okay. So what you do is you take your dictionary. First, you take these letters and you alpha sort them, right? So it becomes EPR, right?
Okay.
Correct. So far with me?
Yes.
Okay.
So you have drawn tiles. So you're playing a game of Scrabble and you're saying that I've drawn these tiles.
Yeah, you've drawn EPRSS. You've drawn all this. Okay. This one is like the first thing that you keep on the board, right? That is what this thing is. This is the very first one, which means there is no connections. There is nothing.
Correct.
And there is only one way you can keep it, so there is no advantage of double score, triple score, quadruple score, none of those apply.
Right.
Okay, so if I drew the tiles E, P, R, S and S, right, if this is what I drew, right, then what I do is I have my entire dictionary which may contain like A, Adam, like apple and all these things, right?
Right.
Where all these things are there. So now what I do is I take my dictionary and I sort the dictionary in such a way that it's all alpha sorted. Does that make sense?
What? Okay.
Why do I alpha sort it?
Got it. Yeah.
Because anagrams, right? In anagrams, how do you compare if 2 strings have the same set of characters? You just sort them in one unique way. It doesn't have to be alpha sorted. You can sort as long as you're consistently sorting it in the same order, you're fine.
Right.
I recommend sorting it in the reverse order of the token cost. So Z and Z and Q and J and X and all, they'll come in the front and whatnot. It might help is what I'm suggesting. Okay, that is one. So so far with me. Now that you have done this, right? So what is the difference between this ABER and EPRSS? You got the E, you got the R, right?
Right.
You didn't get the A or you didn't get the B. Correct? So which means that you still have 2 more tiles to match, and the score that you have is only 2 points because E has 1 point and R has 1 point.
Okay.
At some point of time, you will also match EPRSS, which is a max anyways in this case. Correct?
Correct.
So this works. Now, if you had blanks also, right? So far, are you with me?
Yes.
Now, if you actually had blanks also, then what you'll have is that in this case, right, you say 2 more tiles to match, correct?
Yes.
And since there are 2 blanks, you will say this word is possible. Okay. Now maybe there is a word called express, right? EEPRSSX.
Right.
Okay, and what is the score for this? The score for this will be the same as EPRSS anyways because it's the same score.
Right.
And it will say 2 more tiles to match. Okay? Can you make this word? Yes, because you have 2 more blanks, right? So you say possible.
Okay.
Can you make Adam? No, because you need 4 tiles to match. You after matching all the tiles you have, you still need 4 extra tiles to make Adam.
Right.
But you only have 2 blanks, right? So you can't do it. So you will say not possible.
Okay.
So you take every string in the dictionary, in the sorted dictionary essentially, the characters are sorted in the every word, and then you figure out which ones are possible and not possible, and you're computing the scores based on the matches, and then you're going through this. Now there are a few other optimizations you can do to make your life easier and improve the probability of hitting a better answer faster, but I'm going to leave that out. Okay.
Yes. Okay. I got it this time.
Okay, no worries. And any questions? Right. Perfect. So now let's move on to the next question, which is essentially the Jacobian message. Okay. So I'm just going to paste the question. Like actually, just FYI, all of these questions are questions they're all standard questions that have been used in multiple forms, multiple ways. I've just taken a little bit of a twist and a spin on it, and I've tried to combine a few concepts so that it actually makes sense. So Jacobian message is actually it's JCB is Jacob. Unfortunately, his A and O doesn't work because none of the vowels are working. So what he does is that whenever he wants to type a message, he will type. If he wants to type "I am happy," it ends up coming out as MHPPY because no I, no A. So that's what happens, and no space. Now your goal is that if I give you any string, you need to tell me if Jacob could have possibly typed that message. Right? If you find a vowel, then Jacob could not have typed that message. Correct? If you find a space, then Jacob could not have typed the message. So that's okay. The bigger deal here is that you need to make sure that every word is a legal word. That is the problem, right? That is why you need to use a word list here. So that is the crux of the question. So it's actually multiple things. Not only you are actually looking at the AEIOU is missing, you need to actually repopulate the AEIOU and reconstruct the sentence that Jacob could have possibly typed. There may be multiple avenues. I mean, it could be I am hippie versus I am happy. You don't know, right?
Right.
But that's okay. But MHPPY is a valid Jacobian message. There is at least one way of doing it. Like Jacob could have meant at least one thing. So it's a true. Okay. How do you go about solving this?
One question I had about this Jacobian message, because in your in the QotD chat you had mentioned that Q cannot be regarded as a Jacobian message.
Why?
I was thinking QUEUV. You can with Q. I can make.
Okay, so that you're right. My miss. Unfortunately, I thought I couldn't make a word without that, but you're right. Correct.
Okay.
Yes. So I'm trying to see. Are all letters actually like that, where you can always make something out of it?
Exactly. That's what I was also wondering. Is there like one with every consonant? Can you put a vowel and still make a word? That's a word. It may not make a valid sentence, but a word. And
no, if Q was not in the dictionary, then how do you solve it?
If Q was not in the dictionary.
QUE is not the dictionary. Now what do you do?
Oh, okay. I haven't. Whatever little I thought about this question, I thought the dictionary has to be pre-processed in some ways to using the final string and the vowels to help you out with the final answer. Now, how to pre-process the dictionary or what I need to do, I'm not sure. Something which says that your word should contain either AEIOU or one of AEIOU or multiples of AEIOU and singles of MHPPY. As in, the minute you use your M, you should not use it again, and the minute you use a H, you should not use it again, and etc. So, I don't know how that can be done.
Hey Vivek, can I take a stab at it?
Go for it.
So I was thinking, I'll pre-process the dictionary and remove all the vowels to come up with new valid set of dictionary word without vowels. Okay, and then
so just I'll stop you right there for 1 second, right? Did anybody else actually think of this as an option? Like, since Jacobian phrases do not contain vowels, why not just pre-process the dictionary and eliminate all the vowels from the dictionary words? So a word like I don't know, Ben will just become BN, and tree will become just TR, and so on, and you're just done, right?
I was thinking the same thing, and it boils down to the word break problem.
Precisely. So once you have actually filtered the dictionary down to this, down to like a vowel-less dictionary, then it's a classic word break problem.
yes, exactly.
Right. So this problem essentially is like, we have done this classic word break problem multiple times. You go to any website, anything that talks about this whole this string manipulation, whatnot, you will find this word break problem always. Right. The only element of twist here is the fact that you have additional keys missing. Now, how do you deal with that? Is essentially what it is, which is essentially remove the keys, remove the letters from your dictionary, and obviously condense your dictionary, right? Because a lot of these things will now bin and ben and ban will all become bn, right? So you will have to take the unique lists available to you, and that's it. Then it becomes a word break problem after that, right? Does that make sense? Okay, so Vikas, why don't you walk us through the word break problem?
Okay, so for word break problem, what I was thinking is, let's say so it's very dynamic programming. So start between index I and j. So say if I can make a valid list of words between I and j. So what I do, I consider a logical OR condition for consider every k and see if I to k and k to j, or I to k and k plus 1 to j, I can.
Are you typing? I can't see you. Where are you typing?
Okay, sorry, I didn't type. Valid.
Oh, okay, sorry, that's okay.
I to k and
Plus
valid k plus 1 to j, and do a logical OR and vary k from starting from I to j minus 1, and this will be my recursive condition, and then base condition, and then recurse on this. So basically introduce, and also one more check. If I to j is part of the dictionary, then it's a true. So,
or if you've already disambiguated I to j, right?
Yeah, or already remembered I to.
Yeah, because that will happen, right? Because you would have from 7 to 9, you would have already figured it out multiple times.
Yes, yeah. So a memorization somewhere, and if I to j is part of dictionary, then it's a true.
Any concerns? Sweet. It's actually pretty tiny question, right? If you know what you're doing, it's actually a few minutes. That's it. Any concerns? Vamsi, you had. I think you also had the same idea, right?
Yeah, I have the same.
Perfect. And Rajiv or Kanika, any questions?
No.
All right. So feel free to jump in. I mean, I know if you've not seen this question because this is I know I just like invited you to this one, but feel free to pitch in. All right. So let's jump on to the last question that we have for this week, and this one's actually an interesting question. I have seen the opposite question, and I just thought it will be fun to do the reverse, which is essentially extracting the words from a blender. Right? Hey, quick question. Who is this 8 for like a number ending 4540?
That should probably be me, Rajiv.
All right,
My
excellent.
phone
Excellent.
gets disconnected.
No, that's okay. That's okay. Now, I think usually people connect their online session with the phone. There's a way to do that, but that's okay. That's fine. I see you twice in the list. That's perfectly fine. No worries. Don't worry. All right. So going back to this thing, right? So extracting the words from a blender. So this one is a pretty interesting question where what we're trying to do is so you know you're familiar with merge sort kind of a thing, right? Merge operation. So if I give you like a whole bunch of words, right? Pick the first character from any of the word, like take one character from any of the word, like front of any word. It's like merging of queues. Assume each letter is actually a queue of, each word is a queue of letters, and then you have like n queues available. Now you just take the first, the top of any queue at random, and you finally found like you form like a word. Like if the words were SDE and skills, right? It could be SS, DK, ILELS, and that's fine, right? Now your goal is that given this, extract the source word that were actually merged to form the string. There may be multiple solutions. How would you solve this?
Yeah. Wait, can I take a stab? Actually,
Sure, Vikas. Go on, Vikas.
I shared my solution. The way I was thinking was completely reverse of the merge sort. So the way we do merge, I was thinking of keeping a queue of partial words I have formed. So start that queue with just an empty string, in a empty string, and in order to see next valid choices, I need my input. Whatever the remaining input, and the dictionary words in a try. And as I see a valid next choice, I put that option in my partial list of words. If it's a full word, then I'll remove it from the list. But if it's a partial, I keep track of all the partial words I have. So sort of reverse of merge sort.
You should not remove a full word. Because like if I had the word like axe, right, AXE, you just take A, and A is a full word and you remove it, you're done.
No, I'll take all. I'll do backtracking. So go down one path and then backtrack. The next valid word I can start with. So let's say if the string is X, I take A, and what is the next valid word? So
I think I'm just saying the word is the letters. It's A, S, D, S, E, T. Right? This is what I have. 101, 901. Go for it. Tell me how you do it.
So the algorithm will walk. So the queue will be empty in the beginning, and my input is A, S, X, E, E, A, and my dictionary is, let's say, A. What is the dictionary? Sorry.
The dictionary has, let's assume it has, the actual words are axe and C.
Okay. So my first choice is anything which I need to add partial which will start with A. So I store A partial. Okay, this is my list, and my remaining list input is EXE A. Now on my next recursion, I look at, okay, what is the next, either add something to the empty string or add something to A. So to A I can add an X, and to empty string I can add an S. So S is, let's say S is one choice, and I have two partial words now. But then when I backtrack, I again see if S can be added to A, but S cannot be added to A, so that won't be a valid choice. But
S can be added to A. I don't know. Maybe ass is a word. It's in the dictionary as well.
Okay, if as is the word, then
but as is not in the answer. Like A is in the dictionary, as is in the dictionary. Okay.
Okay, so if for example A is in the dictionary, then I have two choices. One is A is terminal word, and I remove that, so I take that branch and go down, and also take the A as a partial word in the branch. So I take both the choices. So explore all branches, but I'm sending the branches based on what is a valid next choice.
I see what you're doing. I see what you're doing. I think it can be a little bit more efficient than that. We'll just walk through that. Any other choices? Any other thoughts? How have others done this?
So how about doing longest common subsequence?
How would that work?
So the thing is, like, we will try with longest common subsequence.
For all words in the dictionary.
Alphabet. And then, for example, for this particular example, SSGKILS, then I can find, okay, SGE is the longest subsequence of this word.
Which word?
So then I can find, okay, this
so
is
the inputs are the SDE and skills are not given to you. That's what you're supposed to extract. The only input given to you is SSDKILELS. That's it. And the dictionary, which contains a ton of words. Does that make sense, Rajiv?
Yes, that makes sense.
So if that were to be the case, how would you, like, this approach won't work, right? You can't do longest common subsequence, because with what? You need two entries for that, right? Yeah. So let me just walk through this approach, right? So there are two things here. So I think what you suggested makes sense, Vikas. But here is how I was thinking of it, right? So I'm going to maintain like essentially a set of essentially I'm going to call it like word/word prefixes. Okay. And I want to keep this thing of like remaining letters. That's it. So I'm going to have this. So in the beginning it is just empty, comma, ASXEEA, correct?
Yes.
So now I take the A and I put it in the first thing. It's identical to what you said, but I will not actually distinguish between a partial word and a full word. Okay. SXEEA. Okay. Now when it's time for the S, right, there are two things I can do. I can either disambiguate this, or I can disambiguate A, comma, S. Right? Either S is a part of the word A along with its AS, or it is actually two different words, A and S.
Yes, yes.
Then the next one becomes ASX, comma, with EA, or AS and X, EA, or AX and S, EA, or, does that make sense? A,
yeah, that makes sense.
SX, EA, or A, S, X, and EA. Does this make sense?
Yeah, makes sense.
It's very similar to what you said, except that I'm not distinguishing between word ends and word and like end of words and not end of words.
Yeah.
Okay.
Yeah.
Now at any point of time, right? Like for example, if there is no word beginning with ASX, then I can kill this entire branch. It doesn't make sense. I don't have to go disambiguate this.
Yes. Yeah. Exactly. This is what I was thinking with the.
But the only trick here is that I don't think I want to distinguish between a word end and a not word end, because I don't care.
Yeah.
Because because one of the branches will contain that. No, one of the branches will cover that.
Yeah.
Make sense?
Yeah, makes sense.
Okay. Now here's the alternate approach that actually will work, which is that this is actually what Rajiv was saying, but in a slightly interesting way. Is that now let us say I have ASXEA, right? What word can you make starting with A from this? either the word will contain S or it will not contain S, correct?
Mm-hmm.
So let's say it contains S. Okay, so essentially you're saying that if I want to make a word starting with A, using characters S, X, E, E, A in this order or not, that's what you're trying to say. That is either it is a word beginning with A, X, E, E, A, or A, S with X, E, E, A, S, sorry, and so on, right? Does that make sense?
Sorry, wait. Oh, I missed it. You were typing on the bottom.
It's okay. I am looking. I am in line 116. Okay. So the way this works is what happens is that either A is a part of the A is a part of the string. There's no questions there. Okay.
Mm-hmm.
And then I also maintain an array of deleted characters, which is S in this case, and in this case it's still blank.
Okay.
Correct?
Mm-hmm. Yep.
So now once I'm done with this, right, what will happen is that you will find all combinations where you have A is a word, and then you want to figure, so that is like one word, and then you want to figure out if you can actually make words out of S, X, E, E, A, or AS is a word and you want to make words out of X, E, E, A, or AX is a word and you want to make words out of S, E, A, right?
Okay. Yes. Yes.
And so on, right?
Mm-hmm.
Okay, so you will get this. Now what this means is that, so essentially what you're trying to do is it is kind of like finding the longest subsequence, but you're essentially finding, and you can do this with a try. So you're trying to find the longest, find all words that you can make beginning with A in sequence in the string. That's a very simple algorithm.
Right. Right.
Once you have that, all the characters that you have not used, you can actually feed it back to your whole function fresh and try to extract words out of it.
Yeah, this is beautiful. Yeah, this is a beautiful solution. Yeah.
Right? The complexity is no different. I mean, the two different solutions, they're completely distinct ways of doing it, but the complexities are actually depends on the data source and the type of dictionary you have. Okay, so in one case, you're actually parallelly extracting all the strings, all the words. In the other case, you're actually extracting one word which begins with the first letter, and then you're actually processing all the characters that you have not used for further processing and extracting more strings out of it. That's it. As simple as it can be.
Right. Yeah, makes sense.
Okay. Any concerns? Any thoughts? All right. Okay. So that's all we had. I think this is it. So one thing is that next week we will not have the video session. I want to try to see if we can have the question of the day for the 4 of them, and we will not have this video session primarily because I'm actually traveling next week, so I will not be available for this chat, so we won't do it, but we'll definitely have I think the question of the day. I'm going to continue doing that for next week, and on top of that, if for folks who are actually watching this video separately, if you want to be a part of this, you should get to the question of the day is actually something that we discussed on the Slack channel. I think I invited 2 people separately to this one. So if you look at this, you need to get to SD Skills Slack. The way to get to that is if you go to bit.ly/slack to learn. SLACK, Slack to learn. If you go to this URL, it will actually ask you for your email and name, and then once you sign in, it will get you set up with Slack. And once you're there, please follow the question of the day channel. If you attempt even one question that week, you will be invited to this discussion, and we will have a chat and we can talk through the solutions, and I'd love it if you can actually present your solution here. We haven't gone down to the code level at this point of time given the timing and everything, but I will try that out one of these days. So thank you so much for taking the time. I'm going to turn off the recording and I'll be here for another 5-10 minutes in case you have more questions. All right?